We have seen relative motion in the last section. We will do an example on it. Okay. We have that first here. A train is traveling at a constant speed of 90 km per hour and crosses over a road. If car A is traveling at 67.5 km per hour along the road, determine the magnitude and direction of relative velocity of the train with respect to the car. So here, what we want to find is the velocity of the train with respect to the car. So it's Vt relative to the car. So it's simply velocity of the train minus velocity of the car. Okay. So we need to determine, these are vectors, so we need to express them in a frame. We take the xy frame like this. We have that the velocity of the train is directed in I along I, so it's plus 90I. While for the train, we decompose it into two components. We know the angle here is 45 degrees, so we can simply write that the velocity of the train with respect to the car is equal to 90I minus, for the velocity of the car, we will divide it, as we said, into two components. So it's 67.5 cosine 45 along I plus 67.5 times sine 45 along J. Okay, so here this is the vector. So along I have in total 90 minus 65.5 67.5 cosine 45. This is along I, and along J I have plus minus this component, so it's minus. So now, once I do this, to find the magnitude of the relative velocity, I do radical of x component square plus y component square. And for the direction, how to determine the direction? I can see from my result that it has a positive I component, negative j component, so I can represent it like this. This is my velocity vector. And to give the direction, I should define this angle here. What is the value of this angle here? So to find this angle, I am in the fourth quadrant. So, and I put that my angle theta is tangent minus 1 is equal to tangent minus 1 of v relative y over v relative x, and I put absolute value. Okay, why we put absolute value? So I take the absolute value of this absolute, since I know the quadrant and I just need to find the value of the angle. Okay, any question on this? Okay. So another problem. Plane A is flying along a straight line path, while plane B is flying along a circular path, having a radius of curvature rho B equals to 400 kilometers. Determine the velocity and acceleration of B as measured by the pilot of A. So in this problem, we have A in translation and B moving along a curve. So as you remember, we said to apply the relative relations that we know, the body should be in translation. This is why in this problem they ask for B relative to A and not. They cannot ask us A relative to B because we don't know what to do if we have a rotation of B. Okay? So now we want to find both the velocity of B relative to A and the acceleration of B relative to A. To do this, we start by BB relative to A. It is equal to velocity of B minus velocity of A. As you can see, the velocities are given. So for A, it's along plus J, it's 700 kilometers. And for B, it's also in the positive direction, but it's 600. So I have 600 J minus 700 J equals to minus 100 J. Okay, so this is V of B relative to A. Now, for the acceleration of B relative to A, I have AB minus AA. Okay, look at your figure. What is A is doing translation, and so it will have only a component of acceleration along direction of motion, and it's given to be plus 50 kilometer per hour square in the direction of motion. Now, what we will do to find the acceleration of B? What is AB?
It has two components,
Very good.
tangential and
normal, exactly. So we should divide AB into two components, AB tangential, and from the given it's equals, AB tangential is 100 kilometer per hour square. So here it's a deceleration or acceleration for B?
deceleration.
The deceleration, because tangential acceleration is opposite to the velocity. And you have AB normal like this. Okay, so it's AB. Here you have AB tangential, and this is AB normal. How to find AB normal? We apply the formula. Okay, the formula for AB normal is V squared over the radius of curvature rho. Now pay attention for units. Okay, so here, since V is in kilometer per hour, you can keep it in kilometer per hour, and rho should be in kilometers then. Okay, so it's equal to, the velocity is 600, so 600 square over the radius of curvature, which is 400, so over 400. So now I can just replace in my equation, and I have that A of B relative to A is equal to acceleration of B, which is for AB tangential, it's along negative J, so it's minus 100J, and the AB normal is along plus I, so it's plus 600 square over 400 times I, so this is AB, minus acceleration of A, which is 50, so minus 50 along J. Okay, so in total, I get that it is equal to minus 150J and plus 600 square over 400 I. Okay, so here also, if I want to find the direction, all I have to do is to represent my vector. I have positive I, negative J, so it's also in fourth quadrant, so I put it like this. And if I want to determine the angle, I do arctangent of the absolute value of the Y component over the X component. I get this angle. Any question on this? Okay. So as you can see here, this is a vector, and to find theta, we do tangent minus 1 of 150 over 900. We get the angle here. Another problem, at the instant shown, car A and B are traveling with the speed of 18 meters per second and 12 meters per second respectively. Also at this instant, A has a decreased speed has a decrease in speed of 2 meters per second square, and B has an increase of speed of 3 meters per second square. Determine the velocity and acceleration of B with respect to A. So now in this problem, you have two moving cars, okay, of different velocity and acceleration, and moving along different directions. And we want to measure the relative velocity and acceleration. So as usual, okay, to find the relative velocity, we write that v of b with respect to a is equal to the velocity of b minus the velocity of a. And here, from your figure, okay, the velocity is along of b is along minus j, while the velocity of a is decomposed into two components. So this is vb, it is minus 12j, while for va, I should decompose it into x and y, and the angle here is 60 degrees. So I can write that vb is sorry, this is the acceleration. Look, you can know from the unit here, meter per second square acceleration. This is the velocity. Velocity is downward, equal to 18 meter per second. So we should decompose it into x and y, and its angle with x, with negative x, is 60 degrees. Okay, so we can write that vb is minus 12j. And now for VA, it's minus. I decompose it into two components. It's a negative component along X, negative component along Y. So it's minus 18 cosine 60 and minus 18 sine 60 along J. So cosine 60 is along I, and minus 18 sine 60 along J. So in total, we have that our velocity is along I, it is plus 18 cosine 60. Okay, this is along I, and along J I have minus 12. So plus, this will be positive because you have minus minus. Okay, so you have plus 18 sine 60 minus 12 along J, minus 12 along J. Okay, so now this result will give you the velocity vector of b relative to a, and as usual you can find its magnitude and its direction. Now for the acceleration here, for the acceleration of b relative to a, you have acceleration of b minus acceleration of a equals to, for b, what is the acceleration of b?
Two components.
Two components, because it's moving along a curve. So you have a tangential component. The tangential component is given here. It's 3 meters per second square in the downward direction. So here we can know this without, even if they don't give it in the figure, because they said it has an increase in speed of 3 meters per second square. Okay, so V and A tangential should be in the same sense. However, for B, it's the opposite. For B, it's decelerating. For A, it's decelerating. This is why V and A are opposite, because as A is decreasing in speed of 2 meters per second. So now, for AB tangential, okay, so we have to decompose AB into AB tangential and AB normal. AB tangential is minus 3 along J. Now for AB normal, as you can see here, how is AB normal in this problem? What is the definition of AB normal? It's always directed towards the center of curvature. This is the center of curvature because it's a circular path. So it's like this, directed towards the center. Okay, so it's negative I. Here, why it's along I? Because AB tangential is because UT is vertical. So UN will be horizontal. But if you take any other position, for example here, if the car was here, this will be UN, okay, and this will be UT. So in this case, what should you do? You should decompose UT, UN on I and J, okay? So here, in the particular case here, it's along minus I, and the value of A normal is V square over R, so it's VB square over the radius of curvature rho at point B along I. And now for AA, I should decompose it into two components, okay? So it's minus 2, like I did for velocity of A. So I decompose it, so it's minus 2 times cosine 60 I plus sine 60 J. Okay, so now in total I sum the I components together, the J components together, so I get that along I have first minus VB square, and VB is given to be 12, so it's minus 12 square over the radius of curvature. The radius of curvature is given in the figure, it's 100 meters, so over 100 along I. And I have the second component along I is minus 2 cosine 60. So minus 2 cosine 60. This is the total component along I. And now the component along J is a plus. I have minus 3. And I have from the other side minus 2 sine 60. So minus 2 sine 60 along J. Okay, so as you can see here, I have negative component along I and J, so I am in the third quadrant. If I want to represent it, or the acceleration will be like this, the relative acceleration, negative along I, negative along J. Okay, any question on this? So here you can find the complete solution. Okay, and for each vector, after you find it, you can calculate its magnitude and its direction. Okay, so we are done with this chapter. So as I told you, this is the hardest chapter in dynamics. Now you will see that the others are very simple. So we will start now by the new chapter. Okay, the new chapter is on kinetics of particles. Okay, so for kinetics, I deal with forces. And I relate them with my acceleration. And after I do this, I can find velocity. So always in several problems, you should combine the previous chapter and this one. Okay, and we'll see how. Okay. So first, in this chapter, we will introduce the Newton's law, which will be very important when we deal with kinetics. Okay, so first, the first law of Newton is related to statics. So you have taken this in statics. So you don't take statics. So احنا أخذنا بالfirst part of engineering mechanics, we did the statics part. The condition was sum of forces equals 0 if a body is at rest or moving at constant velocity vector, so without acceleration. Okay, this is the first law of Newton. Now the second law is related to accelerating bodies, and it's stating that if the net force on a system is F and it's experiencing an acceleration A, then I can write that sum of forces and sum of external forces, pay attention, the forces should be external to the system. Sum of external forces should be equal to, it's proportional to the mass and the acceleration. It's equal to m times a. Okay, this is the second law of Newton. Now, the Newton's law of gravitational attraction will give you the interaction between any two particles. So if I have any two particles like this, okay, There will be a mutual interaction between them. And the most common attractive force that you know is the weight. Okay, the weight is simply the action of the earth on a particle. So if the weight is a particular application of this formula. So for example, if I take that the second part is the earth, okay, and I apply this formula, I can say that the weight is calculated as G, which is the gravitational constant, it's a constant, big G, times the mass of the Earth times the mass of the particle over the distance between their centers. Okay? So R, if you want to represent the radius of the Earth plus the altitude or height of the object. Okay? So here, if you look at this figure, for example, this is the total distance. R is the distance separating the centers. So it's from here to here. Okay. So in case of the Earth, I can divide this distance into two parts. I have the radius of the Earth and I have the altitude h, okay, of the particle. Now, in general, you are familiar uh, with a value of G equal to 9.81. What is this value? If you look at this expression, you have the mass of the particle multiplied by what? By gme over re plus r plus h squared. This is G, you know. This is the constant G that you use in W. You say W is equal to m particle times G, mass of the particle times G. This is G. It's gme over the distance between the two centers square. And why you use in general 9.81? Because for small altitudes, and if h is very small compared to the radius of the Earth, I can consider that it will be negligible compared to it because the radius of the Earth is very high. Then I can say that at Earth level or for small altitudes, so for small altitudes, I neglect h compared to the radius of the Earth. Okay, I neglect h, and therefore I get, so G is 9.81. But you know that for satellites, for example, I cannot say that G is 9.81 because for satellites the altitude is very high and sometimes it's much higher than the radius of the Earth. This is why as h will increase, G will decrease. Okay, so in space applications and satellites, you can consider that the weight can go to zero because if the height increase a lot, then with increase of height, the weight will be reduced. Okay, so keep in mind that G is not a constant. We treat it as a constant just near the Earth. So if we are moving around the Earth, but if we have very high altitudes, then G will be variable with altitude and it will decrease as the altitude increases. Okay. Now, for the equation of motion, you have that we said that the second law of Newton states that sum of forces equals to ma. Okay, and we can represent this by two diagrams: the free body diagram and the kinetic diagram. What is the definition of the free body diagram? The free body diagram represents all forces acting on a particle. Okay, so this is the free body diagram. And the kinetic diagram represents vector ma. So it represents the resultant of the forces because we know that ma is equal to sum of external forces. Okay. Now, in case sum of forces is zero, then the kinetic diagram will be reduced to a point, and this is, we go back to the static equilibrium. Okay. Now, if we have a system of particles, okay, we have several particles, we can combine them in one system, and then we can apply some of external forces on all particles equals to ma. But when we do this, we should take acceleration of the centroid of the system, okay? Because when I take a system of particles, they can have different accelerations, so I should find the acceleration of their centroid. How to do this? If you look here at the case, if I take each particle separately and I take into account forces acting on it, the forces acting on it are due to external forces plus due to interactions between this particle and the other particle. Because you know that any two particles will have interaction between each other. Okay? Now, what will happen when I do the summation? This is the equation valid for one particle. If I do the summation over all particles, I end up with the following relation. That sum of external forces on the system plus sum of interactive forces between the particles equals to sum of MIAI. But this term will be equal to what? This term? This one. Sum of interactive forces. Who knows? Look, we said that if we have any two particles, we will have, by action-reaction, the action of this particle on this one is equal and opposite to the action of the particle on the other one. So due to action-reaction between the two particles, what will happen? These two will cancel out. And all interactive forces will cancel out, because if I take any pair of particles, they will act on each other in opposite forces. So this term will cancel when I do the summation. Okay? So at the end, I can demonstrate that if I take a system of particles, I don't need to take into consideration the interactive forces because they will cancel out, and I will only have sum of external forces on the system equal to sum of MIAI. Okay? And we will demonstrate together that sum of MIAI is equal to the total mass times the acceleration of the center of gravity G. Okay? So here, how we can demonstrate this? If you remember, we have seen together in the chapter of, in statics also, we have seen a similar thing. That if you want to if you want to find the centroid of area, what do? You do total area times xg equals to sum AIXI. Okay, this is for the centroid of an area. Now for the center of mass, we do a similar thing, but now relative not to area, to mass. So to find the centroid of several particles, I do m times the position vector of the center of gravity G equals to sum of mi ri, where ri represents the position vector of each particle. So now if you derive this relation, if you derive it a first time with respect to time, you get that the derivative of position is what? Is velocity. So as a first derivative, you get that mass times velocity of G of the centroid G equals to sum of mi, which is the mass of each particle, vi, which is the velocity of each particle. And now if you derive again with respect to time, you end up with the relation we talked about, that the total mass times the acceleration of the center of gravity is equal to sum of MIAI. So if you have several components in your system, you can say that sum of forces is equal to sum of mass of each particle times its acceleration. Any question on this? Okay. So now it's time to apply the Newton law. So as we have seen in previous chapter, we can deal with Cartesian coordinates in x, y, z, or with normal tangential coordinates. So it depends on the problem. Okay, if you have a problem where, let's say, it's easy to work in x, y, z. So for example, if they give you velocity function of time, you can derive and find ax, ay, and az. So you can apply the Newton law in this frame, and then the vectorial relation sum of forces equal ma can be decomposed into three equations, like in statics. Okay, but now instead of putting 0, I have sum of x equals max, sum of y equals may, and sum of z equals to maz. Now keep in mind that if you have a constant acceleration, you can apply all formulas that you have learned in the previous chapter. So sometimes we need to combine the two chapters to end up with our solution, and we will see an example for this. So let us do a first problem. The 50-kilogram crate rests on a horizontal plane for which the coefficient of kinetic friction is mu k equals to 0.3. If the crate is subjected to 400 Newton force, determine the velocity of the crate in 3 seconds starting from rest. Okay, so here, first, what is kinetic friction? You have in dynamics, you have two types of friction. We will see the difference here. You can have static friction, okay, and you can have kinetic friction. The definition of static friction is friction between two surfaces that are not sliding with respect to each other. So if you have two surfaces in contact and no sliding between them, then the friction between them is called static. And if you have sliding, the friction is called kinetic friction. Now here in this problem, how it is possible to have a static friction? To have a static friction, the block should not be able to move. It should be fixed relative to the ground because the ground is fixed. So when the box will slide with respect to the ground, then we are in a relative motion between the two surfaces. Then it's a kinetic friction. Okay. Now, what is static friction? Static friction, by definition, is the resistance to sliding between two surfaces. Okay, and it has a certain maximum. It has a certain maximum. The maximum of it. So this force should be smaller or equal. Okay, to mu s. Mu s is the static friction coefficient. Mu s times normal n. Normal n, which is the reaction between the two surfaces. So I will give you here an example. So here I put P on my crate. Not any value of P can move my crate because if they give me, for example, here, if I tell you that mu s is 0.5, for example, okay? So I give you the value of mu s. Mu s is 0.5 and mu k is 0.3. And I tell you, you will have motion here, yes or not? How you will know? To know if you have motion or not, you should calculate the friction. You can assume that it's static friction. You calculate it, and then you compare it with mu Sn. If it's smaller than mu Sn, then your assumption is right, and no motion for the box. But if it's higher than mu Sn, then you have motion, and your friction will not be any more static. You will have a kinetic friction, and the kinetic friction has one value. It's not like static friction. Static friction can be in an interval from 0 to mu s n. However, the kinetic friction, once you have sliding between the surfaces, directly the friction becomes kinetic, and it will be given by mu k n. So the kinetic friction is equal to Fk equals to mu k n. In this problem, they told you that you have motion, so no need to do any analysis. But I can ask you the problem in a different way. I can tell you I am putting a force P of 400 Newton on the box. Will it move or not? To know if it will move or not, I should give you the static friction and the kinetic friction. So what you will do? First, you will assume that it will not move. If it will not move, then the friction is static. Okay, so you put your friction F, So this is F. Let's say as a first assumption, I will assume that it's a static friction. And what are other forces acting on my box? I have the weight, W, and I have the normal reaction, N. Okay, so here I have, this is N, this is the weight. So first, to find the value of N, do I have motion in Y direction in this problem? Do I have motion in Y?
No.
No, I only have motion in X. So I can write that sum of Fy, sum of Fy equals to 0. Now what do we do? What do we have along Y in this problem? We have minus W plus N, and what also? Do not forget P. You should project P on Y and X. So this is X component of P, which is P cosine 30. And this is the Y component, which is P sine 30. So I should add plus P sine 30 equals to 0. So from this relation I can get N. So N is equal to W, which is the weight is given to be 50, so W is 500. So 500 minus P, which is 400 sine 30. So it is 500 minus 200 is equal to 300. So my normal reaction is equal to 300. Okay. So now, if I want to calculate the value of F, okay, to know if it's smaller than mu Sn or not. So assume, as we said, that it's static friction. So if it's a static friction, this means my box is in equilibrium. It will not move. So as we said, our first assumption, so assume static friction. Okay. So now, since I assume static friction, no sliding between the box and the ground, so the box is at rest. So also sum of Fy, sum of forces along X also is 0. And from this result, I get that minus the static friction plus P cosine 30, so plus 400 times cosine 30 equals to 0. Okay, so what should be the value of S in this case? It is 400 times cosine 30. Okay, let us calculate this value. So just 1 second to see what will be this value.
It's 346.4.
346.
46.4.
Okay. So equal to 346.4. Okay. So now, if I check the condition, what is the condition to have static friction? F should be smaller or equal to mu Sn. If you try to do mu Sn in your problem, it will be equal to what in this problem? In this problem, mu Sn is 0.5 times the normal, which is 300, times 300. It's equal to 150. So it is clear that my assumption is wrong, okay? Because the static friction is the maximum value of it is 150, while I obtained here that the static friction should be 346.4 to avoid motion. So I can conclude, since it's smaller than 150, higher than 150, so my assumption is wrong. So my assumption is wrong, and I will have motion. Okay, is wrong. So the block, yes.
Why 0.5?
Anna, I gave you mu S. Sorry, here 0.5. Mus is given to be 0.1. Mu k is 0.3. Okay, يعني by given I give you mus. هلا here in this problem they told you that it's moving. This is why they didn't give you mus. But I can ask you in this way. I can give you both mu k and mus, and you should know if it's moving or not. Okay. So now, if you want, another question that can be asked is what is the maximum value of P before the box slides? So another possibility of question here, what is the maximum value of P? Just 1 second. So what is the maximum value of P before sliding? If I ask you this question, then you say that to avoid sliding, I should have static friction. Okay? And to have static friction, we said that what is the condition? So the condition to have this is that F static smaller or equal to 150. Okay? So what is the maximum, if you want the critical case, so P will be max for Fs equals to 150. Okay, and then in order to obtain the value of my P that is maximum, all I have to do is to apply that sum of forces along x should be equal to 0. So I get that P cosine 30, P maximum I will call it, Pm times cosine 30 minus 150 equals to 0. So I can get the value of the maximum P that will prevent motion. Okay, so if I exceed this P, then my box will slide. Okay, so it's equal to 150 over cosine of 30. Okay, so now let us continue the problem. So just this was a notice for you to understand the difference between static and kinetic friction. So any value of P smaller than 150 cosine 30 will not induce motion. Okay, and the static friction will be smaller than 150. If I just put a value of P higher than this value, then I will induce motion because there will be sliding between the ground and the box. So here, because P is higher than P maximum, so we will have sliding. And once you have sliding, your body will be accelerating. So now if I put the free body diagram of forces on my box, I have the following. I have the friction, but now it's not F static anymore. It's the kinetic friction. And the kinetic friction is equal to mu k. So it's equal to one value, not like static friction. Static friction can vary from 0 to mu Sn. However, kinetic friction is equal always to mu k times n. And here the value of n is, we have already found it. It will not change. So it's equal to 0.3 times n, which is 300. So it's equal to 90 Newton. This is the friction force. Okay. So now what they asked me in this problem, determine the velocity of the crate in 3 seconds starting from rest. So since I need velocity, I should find first acceleration. So as I told you, you can first from Newton law find acceleration, then you can apply all relations we learned in chapter of kinematics to find velocity, position, and anything you want. Okay. So first we will apply the second law of Newton. You have that sum of forces along x equals to max. Now what are my forces in x direction? This is x direction. So I have a positive projection for P. So it's plus P cosine 30. So plus 400 cosine 30 and minus Fk, so minus 90, equals to m times Ax. M is 50, and Ax will be the only unknown in my equation. I can calculate the value of Ax. Okay, and as you can see, Ax is a constant. Okay, so Ax is equal to 400 cosine 30 minus 90 over 50, which is a constant. Because it's a constant, so I can apply all formulas of constant acceleration. And in particular here, since I need to find the velocity in 3 seconds, which relation I will use from the previous chapter for constant acceleration? I need a relation between velocity, acceleration, and time. Okay, what is this relation? Who will tell me? Who remember? What is the relation between VA and T for constant acceleration? V equals to
Integral.
AT plus V0. Okay, so I have that V, since it's starting from rest, V0 is 0. So V is equal to AX times T, which is here we want for 3 seconds. So V 3 seconds is simply the acceleration in X times 3. Okay. So that's it for this problem. Now, another problem, the system has a weight, we have 3 cars A, B, C. They gave us the weight of A, the weight of B, and the weight of C. And for a short time, the driving frictional force developed at the wheels is Fa equals to 160 T, where T is in seconds. If the truck starts from rest, determine its speed in 2 seconds. And what is the horizontal force acting on the coupling between the truck and cart B at this instant? So here you have 3 cars A, B, and C, and they tell you that you have a force acting on A. The driving force is only acting on the wheels of A, and it's given to be equal to 160 T. And they didn't mention anything about, if you want, friction of the ground, yani opposition from the ground. So you only have the driving friction acting on A. If you want to represent other forces, you have the weight of A, the weight of B, the weight of C, and of course the normal reactions at the wheels. Okay, so I have the resultant normal at A, the resultant normal at B, and the resultant normal at C. But why they don't interest me, these forces? Because they are in Y direction, and I am interested only in X. Okay, so if I want to calculate the speed of my system 2 seconds after starting motion, I should find its acceleration. Okay, so the first step is to find the acceleration of my system. Now, which system should I take? I take A alone, B alone, or I take the whole system? Why should I take here the whole system? Because if you take A, for example, alone, what do you have? You have the force Fa, which is acting on A, but also when you isolate A, you should consider the interaction here between A and B. When you take the whole system, this interaction becomes internal, so no need to account for it. However, when you take A alone, you should put, I have the action of B on A. So this is F of B on A. Okay? And this is the second question. In the second question, they asked you what is the force acting between the coupling of A and B, which is F of B on A, which is equal and opposite to F of A on B. So if I start by taking A, I will increase the number of my unknowns because I don't know the coupling force and I don't know the acceleration. So then I should write other equations. This is why, to simplify my equations, instead of taking A alone or B alone or C alone, which will involve new unknowns, I can consider the whole system. So when I consider the whole system, the coupling forces between A and B and between B and C becomes internal to the system. And in X direction, the only external force will be the force acting at the driving frictional force acting at the wheels of A, which is Fa. So now if I take a system AB plus C, so always when you do the second law of Newton, you should specify your system. Okay, so I will take a system here, A plus B plus C. Okay, so I have here that if I consider the positive direction of X like this is, if I consider this is my positive direction, so if I write sum of X in this direction, I have that sum of X equals to the total mass. The total mass is MA plus MB plus MC times the acceleration A of the system in X direction. Okay, so the only force in X is 160T. So it's 160T equals to find the mass of each car, I should divide the weight by G. So if I take G10 for simplification, I have that the mass of A is 360. The mass of B is 220. And the mass of C is 130. Okay, times AX. So now AX will be equal to 160T over the total mass. Okay, over M total. So if you want, I will write it as follows. It's a constant. Okay, it's equal to a constant C, which is 160 over M total times the time T. So please here pay attention. A is not constant, it's function of time. Okay, so I can never apply the relations, for example, V equal AT plus V0 here, because A is not constant. So if I want to find now the speed in 2 seconds, what should I do? Always, when A is not constant, I do integration. Okay, so now, since I want to find velocity, and I know that A is equal to dV by dt, what I can do is I can do separation of variables. So I do separation of variables, and then I will get that dV equals to a constant times dt. Okay, so it's a constant times t times dt. So if I integrate, I have v minus v0, okay, equals to c t square over 2. Okay, because I integrate from the side of velocity between v0 and v, and in the side of time from 0 to t. So I get ct square over 2. And since my system is starting from rest, so v0 is 0. So this is v as a function of time. So I can now calculate v at any time. In particular, they asked for v at 2 seconds. So all I have to do is to replace t by 2, and I get the value of velocity. Okay, so that's it for the velocity. Now, the second question, what is the horizontal force acting on the coupling between A and B? So now to find the force between A and B in the coupling, I will take A and I will take B. I can take A or B, one of the two. Why? Because you know that by action reaction, okay, if B is doing on A force, then A will do on B a force that is equal but in magnitude but opposite in sense. So here this is F of B on A, and by action reactions this is F of A on B. So you can take, if you take A or B, you will obtain the same magnitude of F, which is the coupling force between the two. Okay? Now, if you take A, don't forget also to add what? To add FA. because FA, they said that the frictional force is only acting on A. So you should add here FA. So if you take A as a system, what will be your equation? So if I take A as system, I have plus FA minus F of B on A equals to, since I take A as a system, I put M of A times AX, okay? While, so this is if I take A as system. My second possibility to find the force F is to take B as a system. So what will be the difference? If I take B as system, the only force acting on B is what? It is true what I said. This is the only force acting on B, or I have something else. If you take B alone, okay, then you should add what? You should add the force here between B and C also, okay? So you have here F of C on B, okay? So this is why it's not good to take B alone, because you will induce a new variable. If you want to take instead of A, you should take B plus C, because if you take B and C together, then the internal force between B and C will not appear, and you will only have then the force acting on them, the external force acting on them, will be the action of A. So this is F of A on B. So to find F of A on B, you can take or A alone or B plus C, okay? So if I take B plus C, what will be my equation? I will have F of A on B equals to, since I considered system B plus C, so it's MB plus MC times AX. They have the same acceleration because they are moving as one body, okay? So this is if I take system B plus C, and if you try both, you will get the same result. The two equations will give you the same value of the force, okay? Now, if they ask you find the coupling between B and C, then you can take C alone, or you can take B alone also, because you already know F of A on B, so you can calculate F of C on. Okay. Any
Doctor, I have a class.
Oh, sorry. ما قطش الزوم, so maybe because we don't have a lot of participants. Okay. Yeah, it's fine. Okay. Yeah.
Thank you. Bye.
See you tomorrow. Bye.